Namaste and welcome back to our channel Qubit Education Services. We are solving the IISER Aptitude Test 2019 Physics section, and this is going to be our second video in that series where we will be solving question number 47, which is based on Gauss law. Okay, let us read the statement. A point electric charge Q is placed at a corner of a cube as shown in the figure. Okay, so this is the point charge and we have got the cube. ABCD is its top face. What is the electric flux? Okay, what is the electric flux passing through the shaded surface ABCD of the cube? Epsilon naught is the permittivity of the free space, and we have got four options. All of them obviously contain Q upon epsilon naught, and they only differ in the constant in the denominator 18, 12, 6 and 24. Now if you look here, the problem looks not as straightforward as other problems on calculation of electric flux, because all those problems try to exploit the symmetry. Okay, try to exploit the symmetry. But here there seems to be, at least now, no signs of any kind of symmetry, because this point charge is situated at one of the vertices, okay, here, and it is not even situated at the midpoint of the bottom face. Okay, so we can't definitely use symmetry with this structure. But again, we know that we want to avoid the complicated integration that will involve the calculation of the flux integral E bar dot dA bar. Correct? We don't want to do that. So what we are now going to do is we're going to imagine the following. Okay, so suppose a point charge Q is placed at origin. Okay, suppose the point charge Q is placed at the origin, and let us suppose that along D we have got the Z axis. Okay, let us suppose along this edge we have got the X axis, and let us suppose along this we have got the Y axis. Okay, so you notice that this cube, okay, the given cube will entirely lie in the first octant. Correct? Given cube lies in first octant. Okay, see now why are we doing this? Because we want to exploit symmetry, otherwise it will take a lot of time to integrate. Okay, so given cube lies in the first octant. Now here is the thing, we imagine 7 more such cubes being placed. Okay, 7 more such cubes, one in each octant. Okay, because we know that our 3-dimensional space is divided into 8 octants, just like we have 4 quadrants. Okay, now what is going to be a consequence of that? That is actually going to give us a bigger cube, a larger cube, and this point charge Q will be sitting at its center. Okay, so if we imagine 7 more such cubes, one each in each octant, we get a bigger cube. Okay, bigger cube, okay, whose edge will be twice of this. Okay, whose edge will be 2 into edge of given cube. That is, well, secondary, that is not important. Edge of given cube. Okay, we get a bigger cube, and this is the most important part. Our charge sits, okay, our charge sits at the center of this bigger cube, and this center of the cube is extremely important. Okay, why is it important? Because now we can use symmetry, right? Okay, all right, now let us try to visualize it better. Okay, we know that each cube is going to have 6 faces. That has 6 faces. Okay, now one of the 6 faces will be containing ABCD. Okay, but in addition to ABCD, there will be 3 more such squares which will be constituting that face. Okay, which is in a plane above the XY plane. Okay, and parallel to XY plane. Okay, so let me try to draw it here. Okay, that face will look like this. Okay, something like this. Okay, something like this. So note that it already has this ABCD as a part of it, but now we are going to get 3 more such things. 1, this is 2, and this is 3. Understand? And this is to be expected from each face of our bigger cube. So although it has 6 faces, ABCD like I would say faces will be 24, isn't it? 24. Why? Because each face is actually made up of, each face of the larger cube, bigger cube, is made up of 4 of such faces. Correct? Okay, now we can apply the Gauss law for the bigger cube. Okay, by Gauss law. Now why can we apply the Gauss law? First of all, because we have now got a closed surface. Okay, by Gauss law for the bigger cube, the flux of the electric field, okay, which is the surface integral of electric field, okay, dot product, of course, larger cube or bigger cube, how much will it be? It will be the charge enclosed. There's only one point charge sitting at the center divided by epsilon naught. Okay, you know that. But now, due to symmetry, again because the charge sits at the center, so due to symmetry, 1/24 of phi e will pass through each face like ABCD, isn't it? And that argument is important because that is actually going to give us the answer. Therefore, Q divided by 24 epsilon naught is the answer. Okay, observe that if we had the bigger cube itself, then through each face of the bigger cube it will be Q divided by 6 epsilon naught. Okay, but that is not the option because that is a larger cube. Now if we consider one face of that larger cube, you'll find that it is actually made up of 4 smaller faces, and one of such faces is ABCD. Correct? So we have to further split that flux into 4 equal parts, and therefore it's not Q upon 6 epsilon naught, but it is Q upon 24 epsilon naught, which is option D. Correct? So that is 47. We had to be a bit innovative in this solution, in this problem solution. Okay, but otherwise it is easy. So that's 47. In our next video we will be solving question number 48.